We have observed the formation of giant planets in the disks around young stars before. But now, for the first time ever, we've discovered a planet-forming system that turns the clock back even further, right to when the first specks of planet-forming material were created. Are we witnessing the dawn of a new solar system? Planets are born around young stars, which themselves form from giant clouds of gas and dust. These clouds collapse, and gravity from the nascent stars pulls in most of the material. The leftovers form a flat disk around the stars, a so-called protoplanetary disk. Tiny specks of dust and pockets of gas condense into solid material, and they collide and coalesce to form larger clumps, called planetesimals. Over millions of years, these grow further to finally become rocky planets, or the cores of gas giants. Our Sun and its planets, including Earth, formed in exactly this way. If you want to know more about that, check out the video in the description. Now, a team of astronomers have observed a new planetary system, HOPS 315, that is causing a lot of excitement in the kind of nerdy circles I move in. It appears that, for the first time ever, we're witnessing the creation of the first specks of planet-forming material, and the moment a new planetary system is born. But how exactly do we know when the clock starts ticking on the formation of a new planetary system? Well, we look for the oldest solid materials. When a planetary disk is first formed, it is extremely hot. Generally, the first things that cool down enough to solidify are crystalline minerals containing silicon monoxide. In our own solar system, these minerals are found trapped within ancient meteoroids. Many of them have not changed over time and still hold the key crystalline minerals that geologists can use to date our solar system. And the best thing? We can analyze them right here on Earth. Like this meteorite here at the ESO supernova, a visitor from the asteroid belt between Mars and Jupiter that may have been orbiting our Sun since the beginning of the solar system. It was by radioactively dating rocks like this that we were able to date back the birth of our solar system to 4.6 billion years ago. Back to HOPS 315. What astronomers found in this planetary system is evidence for crystalline silicates just beginning to solidify. Specifically, they found silicon monoxide in its gaseous state and within crystalline minerals around the protostar. This suggests that they are witnessing the exact moment when it turns from gas into solid, and that we are seeing the very moment when the first specks of planet-forming material are created. As one of the involved scientists said, this process has never been observed in a protoplanetary disk before, or indeed anywhere outside our solar system, which makes this finding truly exciting. However, the initial observations gathered with the James Webb Space Telescope weren't sharp enough to figure out exactly where in the protoplanetary system the signal came from. So the researchers turned to ALMA, in which ESO is a partner, to get data with better spatial resolution. With the ALMA observations, the team were able to determine that the signal they had picked up with JWST was indeed coming from the protoplanetary disk, tantalizingly from a region close to the star, at around the same orbit as the asteroid belt is in our own solar system. So, in HOPS 315, we're seeing this material at the same distance from the star as we find rocky planets and asteroids in our own solar system. Witnessing the dawn of a new planetary system is really cool in itself. But what makes HOPS 315 even more exciting is that it appears to look very similar to what our own solar system did 4.6 billion years ago. So we can use this planetary system as a probe to find out what happened while Earth was forming and unravel our own cosmic history.